In the last video, we talked about demand from a principles level, very sort of theoretical approach to what demand is, what we mean by demand, what demand looks like, how it behaves, those sorts of things. Businesses absolutely want to know what their demand looks like, how it behaves, those sorts of things. One of the most important things that businesses get from knowing about their demand is the elasticity of their demand. We talked about that last time, what elasticity is, how we measure it and stuff. In this video, I want to focus specifically on how elasticity and revenues are linked, because a lot of the pricing that we see, whether it's airlines charging different fares depending on the day, or movie theaters charging different prices for students or adults for matinee versus evening, is based on elasticity. And so we want to focus in on this video in terms of how our elasticity and revenue link together, and if a firm knows about its elasticity, how can that help it in terms of its decision making to make more revenue. Okay, so at a basic sense, we've talked before about how firms are trying to maximize profits. One aspect of profits is revenue, so we're going to focus on revenue here. Costs are sort of in the background, and we'll deal with those later. But in the most basic sense, total revenue is just price times quantity. How much do you sell, which is quantity, and how much do you sell it for, which is price. So what elasticity tells us, if you remember back to the last video, elasticity tells us how responsive quantity is to a change in price. Okay, so notice when we say how responsive quantity is to a change in price, quantity and price are two elements within total revenue. So if we know how responsive quantity is when we change price, we have a sense of what's going to happen to our revenue. So for example, my hypothetical here, what if we know that our measured elasticity, this from the last one, is less than 1, what should we do with price? Okay, so last time we said we look at elasticity, compare it to 1 in absolute value. If it's less than 1, we say demand is inelastic. If it's greater than 1, we say demand is elastic. Okay, so in this case, we're less than 1. Demand is inelastic. Inelastic means that the quantity demanded does not change very much when price changes. So if you want to go super extreme, maybe quantity doesn't change at all when price changes. So if that was the case, if you're going to sell the same quantity regardless of the price you charge, it becomes obvious that you want to raise price. So in general, if we know demand is inelastic, what should we do with price? We should raise it, because quantity is not very responsive. So when price goes up, yes, quantity will fall, but it's going to fall by a much smaller percent. So it's like we raise price 10% and quantity falls, but maybe it only falls 1%. So overall, we come out ahead. Similarly, if we know the elasticity, our measured elasticity, is greater than 1, we know demand is elastic and quantity is highly responsive to changes in price. So there the hypothetical would be we raise price maybe $1 and we lose 90% of our customers. That doesn't sound very good. If we lower price $1, or let's say 10%, maybe we gain 90% more customers. So in this case, we want to lower price. Okay. Now to see what's going on here, let's think about graphing out total revenue. Okay, so here's a demand curve. Nice generic downward sloping demand curve. And then over here on the right, I have total revenue on the vertical axis and quantity on the horizontal axis. So all I'm going to do is I'm going to take these quantities over here and I'm going to bump them over here. And I'm simply going to calculate out total revenue at a variety of points along this demand curve and plot them over here and see what it looks like. Okay, so here's my first point on my linear demand curve. At a price of 80, I will sell 10 units. 80 times 10 gives me total revenue of 800 when I produce 10 units. Okay, my next point. at a price of 60, I'm going to sell 20 units. If I multiply 60 times 20, I get 1,200 in total revenue when I produce 20 units. So there's my second point. Third point, at a price of 40, I sell 30 units. So that is also going to give me 1,200 in total revenue. And then finally, at a price of 20, I sell 40 units. So that's going to give me a total revenue of 800. Okay, so it's a nice linear demand curve. I'm just sticking with the same slope here. Now, if I connect those points, I get something that looks like this. Okay. And this is my total revenue. It shows me for any quantity choice that I make here, how much total revenue I'm going to make. And bear in mind, once I choose quantity somewhere here, let's call it that point, that's going to then dictate that I charge that price. Okay? So when faced with this situation, hopefully it's pretty obvious at what point would firms want to choose. They want this point right here. They want the point that maximizes total revenue. Now again, cost does factor into this, and we'll come back to that. But if you have a fairly constant cost in a lot of circumstances, maximizing revenue does a pretty good job in maximizing profit. Okay, now if we look at this graph, and again, we want to relate this to elasticity, let's think of what does elasticity look like along this demand curve. Okay, so we could calculate the elasticity from here to here, and we could calculate the elasticity from here to here. So up here, we would have elasticity equals, so it's the change in quantity, so 20 minus 10 divided by where we're starting, and we're starting at 10, divided by the change in price, which is going to be 60 minus 80 divided by where we started, which is 80. Down here, at this other point down here, we're going to get elasticity equals, so change in quantity, 40 minus 30 divided by where we started, 30. And then change in price, 20 minus 40 divided by where we started, which is 40. Okay, now while the slope is the same, these are going to give us very different elasticities at these different points. Logically, what's going on? So remember, when we do elasticity, we're talking about percentage changes. So if we're up in the upper left-hand portion of the demand curve, and this will look cleaner in the next graph. In fact, let me just forward to the next slide because it looks a little cleaner. If we're up in this upper left-hand portion of the demand curve, we have very high prices and very low quantities. So any change in quantity is going to be a relatively large percentage. Any change in price, because prices are really high, is going to be a relatively low percentage. So we're going to tend to get elasticity estimates that are elastic, meaning greater than 1 in this region. And notice I also put that over here, identifying the same quantity where we're getting elastic demand. If we go to the lower right, down here we have very high quantities and very low prices. The low prices means that a change in price is going to be a large percentage. The high quantities means a change in quantity is going to be a small percentage. So there we're going to tend to get inelastic demand. So over here, we're inelastic over here. Okay. That point in between is unit elastic, and it's also where demand is, or total revenue is maximized. So when we get in the next module to estimating demand, keep this in mind. What we're really looking for is we're looking for where is demand unit elastic? Where is it equal to -1? And so if we can estimate demand, then we can compare, is it -1? If it's -1, then revenues are maximized. If it's less than 1, we need to do something. If it's greater than 1, in absolute value for both of these, we need to do something. Okay, now what do we need to do? Okay, well, if it's elastic, so over here and up here, we're going to increase our total revenue by producing more and lowering the price. So we're going to sort of move this direction. And if we're elastic, so down here and over here, we're going to increase revenue by decreasing quantity and raising price, so sort of a movement that direction. And we're going to stop once we hit that unit elastic point, which is going to be right there. So estimating this is going to be important, but from a firm's perspective, if they know what their elasticity is, whether it's inelastic, elastic, uninelastic, it's going to help them determine what to do with their prices. So we end up with a very, very easy to use and interpret rule. Okay, so our general pricing rule, if elasticity is greater than 1, and again, in absolute value. Okay, so to remind you from before, we said elasticity has to be negative, therefore we only are worried about the absolute value. So if it's greater than 1 in absolute value, that means demand is elastic. Quantity is highly responsive to changes in prices, so we're going to lower our price and we're going to see tremendous increases in our quantity of sales. If our estimated elasticity is less than 1, that means demand is inelastic, quantity is not very responsive to a change in prices, and so we're going to raise price, because when we raise price, we're not going to lose very many customers. If we get elasticity equal to 1, we're going to keep price unchanged, because as we saw in the previous graph, that's where total revenue is maximized. Okay, now, how do we use this? We can use this, and when we get to the module on estimating this, you'll see where some of these things come from. Elasticities tell us how our demand's going to change, so this is sort of the forecasting component. It's going to tell us how our demand changes when competitors' prices changes, when we have recessions, when we have expansions. It'll show us the impact of our advertising campaigns. There is I won't say unlimited because that's overly dramatic, but there's an incredibly large amount of uses for different types of elasticities, and firms pay huge money to either consultants or hire employees who can help them determine this information. Okay, so here's sort of an example from the real world of using this. In this, it's a little bit older report at this point, but there's a FTC report out there by an economist named Michael Ward, who estimated that AT&T's price elasticity demand is negative 8.64. So greater than 1 in absolute value, highly elastic. Okay, AT&T needs to boost revenues in order to meet its marketing goals, in order to satisfy its shareholders, whatever you want to do. So the question is, to accomplish this goal, should AT&T raise or lower its price? So what we've said before, our rule is if it's elastic, we're going to lower price and we're going to see huge increases in quantity. If it's inelastic, we're going to raise price and we're not going to see much of a drop in quantity when it's uninelastic revenues maximized. So in this case, negative 8.64, greater than 1 in absolute value. And so we're going to lower price to increase total revenue, because we're going to see when we lower price, we're going to get a huge boon in our number of clients or customers. So let's suppose they follow our advice and they lower their price by 3%. And what would happen to the volume of long-distance telephone calls routed through AT&T? Okay, so not only does it tell us raise price, lower price, but it gives us an immediate estimate on, for a change in price, what do we expect to happen to our total revenue? Okay, so elasticity is negative 8.64. That was provided from the report. If we lower our price by 3%, we're going to get an 8.64. So let me show you, make sure we're all comfortable with what we're doing here. So our formula from the last video is elasticity is percentage change in quantity divided by percentage change in price. Okay, now I can multiply percentage change in price times elasticity equals percentage change in quantity. So basically just multiply both sides by percentage change in price. That's basically what I've done here. And so we're going to see quantity goes up 25.92%. So we lower price 3% and we get almost a 26% increase in our quantity of sales. So our total revenue is going to go way up because we have a small decrease in the price and a large increase in the quantity.